Hi, this is Mr. Barr, and in this lesson we are going to simplify the explicit geometric formula. There is a way to simplify them. Goal: I can use exponential functions to model real-life situations. Why? Exponential functions show up in science and economics. I want to understand how they are used. So let's start with the name, your name, and the title of the notes, which is simplifying the explicit geometric formula. So here we go with the notes. Start with your name on at the top. And we are simplifying the explicit geometric formula. So we have a sequence here, 4, 8, 16, 32. And this is geometric. And the ratio is 2. 2 times 4, 2 times 8, 2 times, right? 2, 2, 2. And the generic equation for this is a sub n equals a sub 1 ratio to the n minus 1. That is the generic geometric equation. And so we're going to build this guy right now. So we're going to go a sub n equals 4 to n minus 1. And we just built it. But I'm going to tell you that we can actually simplify this thing down a little bit. Let's see how I'm doing with my notes. It's going to simplify. So right here it is, 4 times 2 raised to the n minus 1 power. It can simplify to this. This and this are the same thing. I don't believe you, Mr. Barr. They are the same thing. Watch. They are the same thing. If I plug a 1 into both of these, I'm going to get the same thing out. If I plug in a 1 right here, ready? Let's plug in a 1. Take this, change into a 1. 1 minus 1 is 0. 2 to the 0 is 1. Times 4 is 4. Plug in a 1 right here. 2 to the first is 2 times 2 is 4. Look, it's building the sequence. Oh, Mr. Barr, that only worked with 1. I don't believe you. Please believe me. Let's try a 2. 2 minus 1 is 1. 2 to the first is 2 times 4 equals 8. 2 squared is 4 times 2 equals 8. Now look, it just built this 8 right here. Oh, yeah, Mr. Barr, you got lucky. It worked with 1 and 2, but it's not going to work with 3. Well, let's see. Does it work with 3? Three minus 1 is 2. 2 squared is 4 times 4 equals 16. 2 to the third is 8 times 2 equals 16. So these two formulas or functions are the same. They're doing the exact same thing. So how do I take this one and simplify it into that one? Well, I'm going to show you. And here's how I did it. What I really used is a new formula. I used a sub 0 ratio to the n. So you start with a sub 0, which means you actually have to take this thing backwards a little bit. So this is a sub 1, a sub 2, a sub 3, times 2, times 2, times 2, divided by 2, divided by 2, divided by 2, divided by 2, takes you to a sub 0. So what we're doing is we're going backwards a step, go back a step, and drop the negative 1. So at a minimum, you can just start using both of these formulas, the unsimplified and the simplified. So why is this working? Well, think about what n minus 1 means to us. It means previous term. This is kind of saying, hey, go back a step. This is saying the value of the first term and go back a step. Well, instead of saying go back a step, I'm just going to go back a step. This is saying go back a step, and so what I'm going to do is just go back a step and ignore and get rid of the go back a step. I feel like I'm losing myself even. So since n minus 1 is saying go back a step, I'm just going to go back a step right away and not even worry about the go back a step up here. If nothing else, just start using this formula as the simplified one. Start by backing out the value of the 0 term, and then just use n. Okay. Find the explicit formula for this. So we're going to do both the unsimplified and the simplified. A sub n equals value of the first term ratios to n minus 1. Unsimplified. Simplified, go back a step, which would take me to 10. Ratio raised to the n. These do the exact same thing. This one is starting at the first term and going back a step. This is starting at the 0 term and not going back a step. Yep, we're looking good. Let's do another one. A sub n, value of the first term, the ratio here is a 1/2 raised to the n minus 1. Now I'm going to simplify it. So instead of starting at the first term, I'm going to start at the 0 term, 50, same ratio, 1/2. Instead of going back a step, I'm just going to start at n. All right, on my notes, I went with a 0.5, and I wrote in a 1/2. It's the same thing. Let's see. Looks like it's going up by 3. Value of the first term. Ratio, n minus 1. Value of the 0 term. Okay, so it was dividing by 3, dividing by 3, dividing by 3. So I'm going to write it as 10 over 3. That's the value of the 0 term, ratio to the n, or maybe as a 3.3 repeating, ratio to the n. Let's see which ones I put on my slide. Okay, so 3.3 repeating. Oh, what's going on with this one? What is going on? Well, we got to find that ratio. So let's find the ratio first. 9.6 over 8. I'm going to use a calculator for that. 9.6. That's 1.2. So my ratio is 1.2. A sub n equals value of the first term, ratio, n minus 1. Now we're going to simplify it. So it was going multiply by 1.2, multiply by 1.2. So So let's work it backwards. Divide by 1.2, divide by 1.2, divide by 1.2. So 8 divided by 1.2 takes me to 6.66 repeating. This is the value of the 0 term. The ratio is the same, raised to the n power. Looking good. And that's it for this lesson. Thank you for watching.